As Canada's population grows, so does our need for energy to heat our homes and businesses. Most of that energy comes from hydroelectric plants, nuclear generators, and natural gas. But we still rely upon coal-fired plants to provide more power when demand is high. Wind turbines are a good secondary source of power, and so are solar panels. But in order to reduce our dependence on fossil fuels, we need more environmentally friendly sources of energy to fill the fossil fuel gap. Biomass is getting a lot of attention as a source of energy. Research is showing that growing plants, including trees, to produce fuel can be economical and environmentally friendly. Biomass pellets can be made from any biological source, such as perennial grasses like switchgrass, miscanthus, and native grasses. Another source of biomass pellets is trees, especially willow and poplar trees. Southern Ontario is home to the largest concentration of greenhouses in North America, and the industry is taking a keen interest in biomass as an alternate heat source. A facility near Leamington is leading the way in biomass energy development. At Ramasco, a variety of biomass pellets are burned to produce synthesized gas that's used to heat adjacent greenhouses. Many greenhouses are 40 acres or more. Keeping that much acreage hot costs growers a lot of money.
Energy is the highest expense we have in the greenhouse industry. And we're looking anywhere between $40,000 to $55,000 an acre. It is critical that we have stable, consistent energy prices. And that's why we are considering biomass as an alternative fuel.
Biomass has already found its way into the residential market. Many homeowners are turning to pellet stoves as an economical alternative to electricity and oil. With all this interest in biomass, the Ontario Ministry of Agriculture, Food and Rural Affairs is supporting biomass research at the University of Guelph. OMAFRA is also coordinating a feasibility study with Ontario Power Generation that's led by a steering committee.
This steering committee is made up of researchers, industry experts, innovators across Ontario. They are looking at all aspects of agriculture biomass for economic, technical, as well as environmental feasibility of these agriculture biomass for heat, as well as combustion energy, as well as power generation.
The feasibility study is a comprehensive analysis that includes every step involved in biomass production. One of the first steps is to compare how willow and poplar trees and perennial grasses grow under various conditions. To find out, researchers at the University of Guelph are growing them in side-by-side test plots.
The problem you have in Ontario and in a lot of other areas is that, people say, miscanthus or willow will yield so much, and it will yield more or less than another species. But until you have them in side-by-side trials, you really can't make those claims and substantiate them. And so now we've established, in collaboration with Dr. Thevethason and Dr. Gordon, trials where we can compare side-by-side productivity, biomass properties, that sort of thing, across species. And those trials are very important.
But as you'll see, research is already showing that willow and poplar trees have some distinct advantages over perennial grasses as a source of biomass. Biomass made from trees is called woody biomass. Woody biomass research is underway right across Canada, supported by the Canadian Wood Fibre Centre, part of the Canadian Forest Service of Natural Resources Canada.
The reason we're into the biomass end of things is now it's a new opportunity. We're looking at clean energy, we're looking at carbon sequestration, so we're looking at purpose-grown woody crops, as we call them, which ends up being biomass like what you see around you, beside me here and behind me. And what these are tree species that we're trying to adapt to agriculture land management scenarios so that we can look at expanding the forest, we can look at growing purpose-grown fiber, so specific biomass that meets specific market needs, like bioenergy, biofuels, and other bioproducts.
At the University of Guelph, a thorough analysis is underway to determine whether growing and processing willow and poplar trees to produce woody biomass can be feasible and beneficial in Ontario. The University of Guelph is home to the largest research plots of willow and poplar trees in southern Ontario.
We've got about 57 hectares of research plots here, and they've been in the ground since about 2006. There's basically 5 areas of research that we're interested in looking at. One is a basic economic analysis, cradle to grave, from production to product, the product being a pellet. The second is a life cycle analysis, where we replace the dollar with a unit of energy. The third is a risk analysis. How risky is this proposition on large scales of the Ontario landscape? The rather mundane aspect of finding out which clone of willow goes best on what type of soil. And finally, are these willows capable of actually improving the sites on which they grow by recycling nutrients?
The woody biomass analysis begins with planting trees. Using a step planter, researchers planted cuttings that quickly rooted and grew. Willow and poplar trees grow well on marginal land, so unlike perennial grasses, they don't use land that could grow food. Research has already shown that with some initial preparation, even a stony field like this can yield a thick crop of trees. It takes 4 years to establish a good crop of willow and poplar trees. After the first year of growth, the trees are cut down, leaving stumps in the ground. Many new stems soon sprout from the stumps, and 3 years later, the trees are ready to be harvested. Naresh Thevithasan manages and evaluates the research project at the University of Guelph.
This dried cut surface is from the Anderson biobaler cut during the harvest in 2009, and what you see here is after the harvest, you could see enormous amount of coppicing stems that has come up from this tool. I just counted them; there are more than 20 from one stool. So just imagine that we start from 15 to 18,000 stems, and then each stem gets multiplied by more than 20. So that is a very unique feature of willow in order to enhance biomass production.
For landowners, growing willow and poplar trees for fuel can become a new income opportunity, and there's lots of support to get them started.
Yeah, we at the Canadian Wood Fiber Centre, we support landowners, forest companies, service suppliers, etc., that are interested in looking at uptake of this new land management regime by basically demonstrating the plantation options in the array of different demonstration sites across Canada. We basically run exhibitions on those sites, and we create models or have created models that present the input costs and output values.
It doesn't have to cost a lot of money to grow willow and poplar trees. For one thing, they need little or no fertilizer. That's because leaves that fall from the trees add nutrients to the soil.
Our research suggests about 2 to 3 tons of carbon is being added annually per hectare, and the nutrients that are released from these leaves while they decompose also helps to sustain the growth of the system during the subsequent year, and this again helps to reduce inorganic fertilizer application.
Trees are harvested every 3 years. A plantation of trees can last for about 22 years or 7 harvests. To harvest the trees, the researchers used a specialized harvester and baler. The harvester leaves about 2 inches of tree stump in the ground, and since it rides above the ground, it can handle rough terrain. Bales of willow and poplar cuttings are loaded onto a truck. Researchers found that using a flatbed truck is best. It takes less than half the time than loading a box truck. 20 tons of willow and poplar bales now make the journey to where they'll be shredded and pelletized. Bags of pellets were delivered to the Ramasco facility in Kingsville, where a variety of pellets are burned to produce synthesized gas. Here, the team of researchers can burn the pellets under controlled conditions.
And we're putting them through one of our units and assessing the quality of gas and the character of the ash to see how they would react in a commercial facility if they were to go into full commercial production.
The researchers utilized state-of-the-art equipment to closely study the combustion properties of the pellets. Samples of gas were taken at 2 stages in the process. Exhaust gas was analyzed during the burn. Another sample of gas was collected for analysis by an independent lab. Back at the University of Guelph, samples of ash are tested for unburned carbon and clinker, harmful residues that can corrode metal and clog burning systems.
We had analyzed the ash that we collected from the Ramasco, and I'm pleased with the result that we have very less ash content and very less unburned carbon within the ash, as well as less clinker within the ash. That are very good things for the willow pellet.
The gas analysis that was taken at Ramasco also yielded good results.
And we don't see virtually any carbon monoxide, and the oxygen content, extoxin that is running, is in the order of 4 to 5%, which is a very good for biomass combustion system.
The final analysis shows that willow pellets burn more efficiently and cleaner than pellets made from perennial grasses. Carbon sequestration is a big part of the woody biomass life cycle analysis. The carbon footprint of the entire process, from planting the trees to burning the pellets, is being carefully documented.
So we are currently doing that life cycle analysis. The project is not complete yet, but I'm quite positive that as long as we can curtail the transportation distance, and as long as the processing plant or pelletizing plant is very close to the site, the analysis should show positive results.
The research project is revealing a lot of evidence showing that growing and processing willow and poplar trees for fuel can be sustainable and environmentally friendly.
Not only are there environmental benefits associated with the growing and the production of these 2 tree species, but at the same time it's very good for the rural economy, and most importantly, it's going to help us get off our dependence on fossil fuels.
For more information about woody biomass research at the University of Guelph, contact the Agroforestry Research and Development Group. A wealth of information is also available from the Canadian Wood Fibre Centre at the Canadian Forest Service of Natural Resources Canada.